Alright, solving the problems on the back, we need to not only factor these, but we're also going to solve it because we have that equals 0. So we've got this trinomial right here, so we're going to factor it by the AC method. So I need two numbers that multiply to negative 35 that'll combine to give us 2. The numbers we need are a 5 and a 7. And the 5 ends up having to be negative to make it all work. Since a equals 1 in our quadratic, I'm going to factor it using our shortcut. Once we've got our two binomials, we're going to find our multiplication dots. There's the one right in the middle. And we're going to use our zero product property. So the zero product property says when two things, in this case, this entire binomial is multiplying this entire binomial, and the answer is 0, then one of these somethings has to end up being equal to 0 for it all to work out. The way you can kind of think about that with our zero product property is if I had some number A times some number B, and our answer is 0, and I told you that A was really 7, well, 7 times what would be 0? B would have to be the 0. But on the other side of the coin, it's getting a little too jumbled up there. If I told you B was 7, then A would have to be 0. Since we don't know which one of those scenarios is it, we take our first binomial and we say it's equal to 0, or potentially our other binomial is equal to 0. Isolate x by adding 5 to both sides. In this one we subtract 7. And there's our two answers that would make this trinomial equal to 0. So if I were to take that 5 and I plug it in there, I get 25. 5 there, I get 10. 25 plus 10 is 35. 35 minus 35 is 0. And we'll get something similar with the negative 7. Next problem over. Again, I need to factor it. AC method, 1 times negative 32 is negative 32. The two numbers I need are 8 and negative 4. Using my shortcut, I get this. Using my zero product property, x plus 8 is 0, or x minus 4 is 0. So negative 8 or positive 4. Next one, 3 times 7 is 21. Any two numbers that multiply to 21, they'll add to 10. It is 3 and 7. So I have to use the long route because a does not equal 1. Factor by grouping, I'm going to take out a 3x. So I get 3x plus 7, x plus 1, zero product property, 3x plus 7 is 0, or x plus 1 equals 0. Subtract 7. Divide by 3. So I get negative 7 thirds, or negative 1. Bottom left question, before I solve anything, it has to be equal to 0. So I'm going to subtract 5 from both sides. I get 16x squared minus 60x plus 56 is equal to 0. I see a greatest common factor of 4. So it gives me 4x squared minus 15x plus 14. So I need two numbers that multiply to negative 56 that add to negative 15. That's a negative 7 and a negative 8. That 4 we took out is just going to chill out in front. Factor by grouping. All I can take is a net, not an x squared, just an x. Apologize. That leaves me a 4x minus 7, which means I need to take a negative 2 to get a positive 4x and a negative 7. That leaves a 4x minus 7, and an x minus 2 is equal to 0. Finding all of our multiplication dots, there are two of them. The zero product property says anything before any multiplication dot, so this 4 could be 0, which it's not, but we're going to check. We just checked anyway. 4x minus 7 equals 0, or x minus 2 equals 0. That gives my answers. I know I'm writing small right there. It's positive 7/4 or positive 2. So that 4 we took out doesn't do anything in this problem. What we could have also done, which I'll do on the last problem, is we could divide that 4 completely out of the problem so we don't even have to worry about it. Middle problem. It's got two terms, but it doesn't have a C term. It will be a plus 0. So we can't use the AC method if there isn't a C. So the only way we can factor this is greatest common factor. We're going to take an x from both of them. Because we took an x from both of them, there's our multiplication dot. Zero product property. Everything before this multiplication dot could potentially be the 0. Or everything after. We subtract that 8, divide by the 5, and that's how we get the negative 8/5. Alright, this one, I'm going to add the 2 to both sides before I do anything. 12x squared plus 44x minus 168 equals 0. I see that every number in here is at least divisible by 2, if not by 4. I'm not 100% confident. Okay, it is. I just wanted to double check. So instead of factoring out the 4 like we did on this first problem, we're going to divide every single number by 4, including the 0. That makes this 3x squared plus 11x minus 42 is equal to 0. Thankfully, 0 divided by 4 is still 0. If we were to look at the front page again, the reason we can't just get rid of this 5 is there's nowhere for it to go. We need another side of our equation. So if I were to divide this by 5, we'd end up with this trinomial, but without the 5. And what I have boxed right here is not the same as what I have typed here. So these are not equivalent. We can't do that. We need the 5. This equation is still equal to itself up there because technically that 4 is hiding right there. I could multiply by 4 again and get back to where I was and nothing would have changed. But thankfully the 0 kind of eats it and we don't have to worry about it. Alright, now we're going to factor by our AC method. I need two numbers that multiply to negative 126. That gives me 11. Ooh, struggle is real. Oh, found it. 7 and 18. I need a negative 7. So 3x squared minus 7x plus 18x minus 42 is equal to 0. I take an x. I take a, need to take a 6 to have my identical binomial. So x plus 6, 3x minus 7. Zero product property says either that equals 0 or that equals 0. That's how we get negative 6 as one of our answers. And 7/3 as our other answer. That is the third section of our homework.